Okay, this will be our last example unless somebody has a little homework question. So we have trig integrals here. Let's look at this one. By the way, most of these that I'm doing on these videos are examples from the book. So let's say I have secant, that's an exponent 6. Gross, that looks silly. Secant to the 6th, 2x is my angle, dx. Okay, so just like we did before. What I really want to see is I want to see something, doesn't matter what exponent it's to, and then I want to see its derivative sitting right next to me. Okay, well, I don't have the derivative here. So that's your next step, is you're going to separate these 6 secants, and what I'm trying to do is establish a derivative. So that's kind of tends to be your first step, is I want to create something that's going to serve as a derivative, and that's going to tell me what my u substitution is going to be. So you have all your derivatives, okay? So somewhere you should have a sheet that says the derivative of sine is cosine, derivative of cosine, negative sine, derivative of tangent, secant squared, then you have negative cosecant squared as another derivative, then you have your secant tangent and your cosecant cotangent, okay? Those are your 6 trig derivatives. I want one of those derivatives to be sitting right there. Well, the only option available is that derivative right there, the secant squared. So that's what I'm going to do. I'm going to break up those six secants into secant to the 4th, and then I'm going to separate these 2 secants. Just kind of tack them on here at the end, because that is a derivative. That's going to be my du. Now I just need u right here. So to tell what your u is going to be, and my u is not going to be secant. So, well, whose derivative of secant? Whose derivative is secant squared? The answer is tangent. So what I want to see up here is I want to see everything there in terms of tangent. I don't want secant, I want tangent. So you're going to go to your definitions. Well, first thing first, I don't have any definitions of anything to the 4th. I have definitions of secant squared, but not to the 4th. So break that up again into those 2 chunks. That's going to allow you to do your definitions. And then don't forget that's times your little secant squared here. Now that part is going to be your derivative. So again, I'm going to just remind myself that's going to be the derivative of u. So look at your definitions for secant squared. You will find one that says the secant squared is equal to 1 minus tangent squared. And remember, you can't change the angle. The angle's 2x. It's got to stay 2x. So I'm going to do that for both of these. I'm going to put them both in terms of tangent using the trig identity. Secant squared x equals 1. Oh, you know what? I put 1 minus tangent x. I'm sorry. It should be 1 plus tangent x for both of those. Times my little... I'm going to put it in blue so that I always remind myself it's separate. Oh, look, I put du, but that should be dx. All right. Do your FOIL. 1 plus 2 tangent squared 2x plus tangent to the 4th 2x. And all of that is times my little secant squared 2x dx, which I'm calling derivative. Okay, so you're ready for u substitution. You already knew that du was going to be your secant squared 2x dx. And you know u is equal to the tangent of x. Derivative of tangent is secant squared. So if you do your u substitution, well, 1 is still just 1. Plus 2 times u. Oh, whoopsie. Let's make a little, we got to make a little correction here. So I'm sorry. I wrote tangent of x, but u has to be tangent of 2x because you can't change the angle. And then I have to be very careful. The derivative of that u would be secant squared 2x dx times the derivative of the angle, which is 2. So I just want secant squared all by itself. So I have to get rid of that 2. So it's actually, so I have to divide both sides by 2. So it's actually 1/2 du is secant squared 2x dx. So I should cross that out. So That's what I have to be careful of when I'm substituting. So tangent squared 2x, so that's u squared, plus u to the 4th. All that is times the secant squared thing is 1/2 du. Okay, so it's times 1/2 du, so I'm going to take that 1/2 out. 2 squared plus u to the 4th. All that is times du. So now I'm just going to do my, I'm just going to integrate. So I get u plus 2u cubed over 3 plus u to the 5th over 5. Don't forget that's times your little 1/2. U is equal to the tangent of 2x. So I have tangent of 2x over 2 when I distribute that 1/2. I'm going to kind of do this all in one step. When I do 1/2 times this 2/3, the 2's cancel. So I just get tangent cubed of 2x over just 3. Again, the 2 times the 1/2 canceled. And then tangent to the 5th of 2x. It would be 10, 1/2 times 5. And that is my final answer.